Good afternoon, ladies and gentlemen. Of course, after we have finished the triangle, we have to go to Pythagoras theorem, which is one of the most important theorems in mathematics, in geometry, of course. So why is it so important? Pythagoras theorem always work on the right angled triangle. Okay, here's the right angled triangle. It's called ABC. Okay, we have studied before, maybe in primary 5, that the side which is opposite to the right angle is called hypotenuse. So, hypotenuse is the side opposite to the right angled triangle, and it's also the largest side in that right angled triangle. So, before we start, I would like to call the other two sides legs. So, we have the hypotenuse and two legs. So, what does Pythagoras do? If I have right angled triangle and I would like to find the hypotenuse as example. Okay, so can I get the third side? Okay, there is a rule to find the hypotenuse. AC equals root AB squared plus BC squared, like this. AB is 3 centimeters squared, BC is 4 centimeters squared. The answer will be 5 centimeters. Of course, we do it on the calculator. So that's simply Pythagoras, that I can find any side if I have the other two sides in a right angled triangle. Of course, if it's not right angled triangle, there isn't a hypotenuse and there isn't Pythagoras. So Pythagoras only works with the right angled triangle. Okay, the same triangle, x, y, z. What if I have the hypotenuse given and I have one of the two legs and I need to find x, y? So it's the same rule but by subtraction. So if I would like to get x, y, root and subtraction. What do you think? Which one minus which one? Of course, the hypotenuse, because it's the bigger. So if I would like to subtract, I must get the bigger side and then calculate it by the calculator. So that's simply Pythagoras. Okay, let's go to some examples to solve. In each of these triangles, of course, this example are in page 47. In each of these triangles, name the hypotenuse. So, where is the hypotenuse in number 1? Excellent. The hypotenuse is AC. Why? Because it's opposite to the right angle. What about the next triangle? Opposite to right angle? Excellent. So, the hypotenuse is XZ. So, before I start, I have to know what is hypotenuse. Let's go to number 2. I have AC 6 centimeters and AB 6 centimeters. So the first question I have to ask myself, what I would like to find? I would like to find the hypotenuse. So BC is hypotenuse. So BC equals root AB squared plus AC squared. Let's substitute by numbers. So 6 squared plus 8 squared would be 10 centimeters. That's it. Okay, let's go to the next one. Of course, I have to write the rule in each problem. Okay, so next one, what would I have to find? It's AB. So is AB a hypotenuse? Yes. So AB equals root 12 squared plus 16 squared. Of course, by using calculator, I can easily calculate it. It would be 20 centimeters. Okay, please try to solve the third one by yourself. Pause the video and try to solve it. So, AC equals root. So, I would like to find the hypotenuse. So, 5 squared plus 12 squared equals 13 centimeters. So in all those three examples, I got the hypotenuse. I found the hypotenuse. Okay. What if the required side is not hypotenuse? Like this one. The AB is unknown, so what's the hypotenuse? Oh, BC is the hypotenuse. So how can I find AB? Okay, I will make the same rule, but as we said before in the video, by subtraction. So, which one minus which one? Of course, the bigger one, the hypotenuse. BC squared minus AC squared. 25 squared minus 24 squared, all of it, of course, under the root. I can solve it easily using the calculator. Root 25 squared minus 24 squared. The answer will be 7 centimeters. Okay. Please complete the other two as homework because they are the same idea. Okay. Let's go to example number 3. It's like a square. So this 4 centimeter, it's a square and a right angled triangle. So I would like to find the area of triangle CDE. I want the area of this triangle. Okay, remember the area of triangle equals half times base times height. Okay, the base is 3 centimeters and the height, of course, is 4 because it's a square. So the area equals half times 4 times 3 equals 6 centimeters squared. This is the area of triangle. Okay, what about DE squared? I would like to find this side squared. Okay, DE squared equals DC squared plus EC squared. Why? Because it's a hypotenuse. So I added the square of the other two sides. So where is the square root? No, DE squared. I would like to find DE squared, so no need to put the square root. So it's 4 squared plus 3 squared. The answer would be 25 centimeters. So I got it with the Pythagoras theorem also. Okay, let's go to the most important example in Pythagoras in page 51. In the opposite figure, measure of angle B equals measure of angle ACD equals 90. So this angle is 90 and this angle is 90. Okay. AB equals 18. AD equals 34 centimeters. And CD equals 16 centimeters. Okay, find the length of BC. I would like to find the length of BC. Okay, let's look at those two triangles. They are two right-angled triangles. So whenever I see a right-angled triangle, I must think of Pythagoras because the only way to solve a right-angled triangle is Pythagoras. Okay, let's look at this triangle ACD. In triangle ACD. Can I get AC? Yes, because I have AD equals 34, CD equals 16. So the last side is AC. Is it hypotenuse? Yes. So I will add the squares of the two sides. Using your calculator, 16 squared plus 34 squared, the answer would be 37.5 centimeters. So now I got AC. Oh, there's a mistake here. Who got it? Excellent. Why did I make plus? Is AC a hypotenuse? No, it's not hypotenuse. Okay, so I have to subtract. So AC equals root 34 squared, excellent, minus 16 squared, because I add the sides if it's hypotenuse, but AC is not hypotenuse. It's hypotenuse in the other triangle, but now I'm in triangle ADC. So 34 squared minus 16 squared equals 30 centimeters. Okay, now I know that AC equals 30 centimeters. Let's go to the other triangle. In triangle ABC. Okay, which side is unknown? BC. I would like to find BC. So is BC hypotenuse or a leg? Excellent, it's a leg. So BC equals root 30 squared minus 18 squared. Again, I did subtraction because it's a leg. If I would like to find the hypotenuse, I will add them. So, using the calculator, the answer would be 24 centimeters, and that's the required to find. Okay, let's go to another example in page 49. The last example in our video, number 5, page 49. D is the midpoint of BC, which means this side equals to this one. AB equals 12, AC equals 20. I would like to find the length of this side. Okay. Again, I have a right angle triangle, so I have to use Pythagoras. Look at the big triangle, ABC. So I have two sides. I have 12 centimeters and 20 centimeters. Can I find BC? Of course, using Pythagoras. So is BC a hypotenuse or a leg? It's a leg. So I will subtract, of course, the bigger one minus the smaller one. So BC equals root 20 squared minus 12 squared. The answer would be 16 centimeters. So all BC is 16 centimeters. Okay. So how long is BD? Of course, BD equals 16 over 2. Why? Because D is midpoint. This part equal to this part. So now I know that BD equals 8 centimeters. Can I find AD? Okay. Let's go to triangle ABD. I would like to find AD, which is hypotenuse or a leg. It's hypotenuse, so I will add the square of the two sides. 12 squared plus 8 squared. So using the calculator, easily I can do 12 squared plus 8 squared, and the answer will be 14.4 centimeters. So now we have reached the end of our Pythagoras theorem, and have a good day.